All right, 1.3, 12 basic functions. So a lot of these are just asking you questions about the functions. It'll say like, which 3 functions, blah, 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 and you have to be able to list out the function. I don't want the name of the function. I want the function written out. Okay? So, example, which 3 functions from the graph do not have the domain of all real numbers? So we would look at our list of graphs, okay? A domain of all real numbers implies what?
There's no imaginary numbers.
Yes, but what?
It's a line.
Doesn't have to be a line. What does that imply x takes on? The numbers from what?
0 to
All real numbers would imply what?
negative.
Negative infinity all the way to infinity. So, which ones do not have a domain of all real numbers? Huh?
Numbers that aren't negative infinity.
No, like which graphs?
Oh.
I need the 3 that do not have a domain of all real numbers.
Greatest measure function.
Nope.
A parabola?
Nope. Do not have a domain of all real numbers. That implies that at some point they stop.
Square root function.
Yes. Square root function. Y equals the square root of x. And that's how you need to write it. Do not tell me the name. Write the function. Now, when you're saying them to me like this, it's fine to say the name. But when you're writing them on your paper, you need to actually write the function. What else?
Sine function.
Nope. You're looking for the graphs that do not have all x values.
Absolute value function.
No, that has all x values.
X squared.
That's the same thing as a parabola. Parabola takes on all x values. Get out your notes and look at the graphs that you drew. It's not that difficult. Huh?
Cubic function.
That takes on all x values. You should have these all written down in your notes. Should have taken up like one piece of paper.
Logistic function.
No, it takes on all x values. If a graph is going like this, it's not going to answer this question. Okay? Look at the ones that are not going out from negative infinity to positive infinity. Should not be that difficult. It's like the easiest question.
Y equals ln of x.
Yes. Y equals ln of x. There's one more. Yes. Y equals 1 over x. Because that one has a problem at 0, so it does not take on all real numbers. All right, which function has a domain of all real numbers minus the sub of 0? So basically it means it takes on every number except for 0, and y isn't 0 in the domain. So which one of the three that we just listed fits this requirement?
The reciprocal.
Yep, the reciprocal one and y.
So there'd be 0 can be in the
Yes. Yep, it would be undefined at x equals 0. There would be a vertical asymptote there. Then, which two functions have no negative numbers in the domain? So out of those three, which ones do not have negative numbers?
Square root.
Yep, square root. What else? Yep, and ln. So all of these questions, we're dealing with domain. This next one is going to be dealing with continuity. Only 2 of the 12 functions have points of discontinuity. Are these points in the domain of the function? So, what is a point of discontinuity? What does that mean?
Where does it continue?
Yes, exactly. Where it doesn't continue, okay? Either there's like a gap and it continues somewhere else, or there's like an asymptote there. That's a type of discontinuity. So which two functions have discontinuity? It can be like a single point, or it can be like multiple of them. So basically, which ones are not one continuous flowing piece?
Greatest integer.
Yes. And what else?
The square root function.
Nope.
Reciprocal.
Yes. So I'm going to give you a little bit more information about these as well. And it'll also, in turn, answer the question about if the points are in the domain or not. The greatest integer function has what we call a jump discontinuity. This might come up a little bit in pre-cal, but it more so comes up in calculus with like labeling the types of discontinuity. But this is discontinuous at every integer value of x. Therefore, it's not continuous. And that would not be in the domain because the domain of this is all real numbers, but it has a point of discontinuity at every value, so it would not be. The 1 over x one, this is an infinite discontinuity, so basically if there is an asymptote, it's going to be an infinite discontinuity, specifically a vertical asymptote. And that is at x equals 0 because that's the value that makes that undefined. However, our domain for this function is all real numbers except for 0, so negative infinity to 0 not including, and then not including 0 to infinity. And so this is continuous at every point in the domain. So it is a continuous function. I'm not as worried about you knowing this like lengthy stuff that I wrote underneath. You would just need to be able to tell me which two have points of discontinuity. All right, so that's a question about continuity. This next one is boundedness. And it says, which 3 of the 12 functions are bounded, which means above and below. So that means which functions have like a max on the top and a max on the bottom. Any guesses? And it has to be like both, where like it hits and turns around. Or like horizontal asymptotes that it can't cross. Two of them are relatively obvious. The other one you may not recognize.
Square root of this.
That one would only be bounded below. I'm looking for bounded top and bottom.
Logistics.
Yep. So y equals, and I also don't care if you write y or f of x as far as that goes. 1 over 1 plus e to the minus x. So that's actually one of the harder ones that normally people don't see right away because it can't cross 0, and then there's an asymptote at, well, a higher up value that it can't cross that either, so it's bounded between those two values, 0 and whatever that value is. What are the other two?
Is it sine and cosine?
Yep. Y equals cosine x and y equals sine x, because they just keep turning around over and over again. All right, the next question is about symmetry. And the question is, which 3 functions are even? So out of my list of 12, which 3 are even?
Y equals x squared.
Yep, y equals x squared. What else?
Y equals x. Absolute value of x.
Yep, y equals the absolute value of x. And last one.
Y equals 1 over x.
No. This one may require you to think back to last year.
Y equals cosine x.
Yes, y equals cosine x. I don't remember if we've done that in this class this year or not, the trig functions that are even and odd. I don't think we've done it yet, but I've had it in like 2 other classes.
So grad total?
Well, I mean, yes, that is what trig functions are, but that doesn't tell you if it's even or odd.
Oh. I didn't know what you were saying.
Okay, so the next questions, this is something that I do different than the book, so I'm going to write it out here, what you need to do. For questions 13 through 18, I'm going to do the even ones with you, then you'll do the odd ones for homework, and I'll explain why when we're done. But they tell you to identify with the exercise from 1 through 12 the functions that fit the description that's given. We're not doing that. You are going to state which function fits the description. They want you to take the description that they give you and match it up over here with these graphs. We're not doing that. Okay, which also means you won't be able to check your answers in the back. So you'll have to ask if you're not sure if you got something right or not. So these instructions are modified, and then 19 through 28 will do the same instructions, except for those already tell you to write the thing specifically. So number 14 says the function whose domain consists of all non-negative real numbers. So which function has a domain that is non-negative real numbers, meaning it goes from 0 to infinity for its domain?
It was like the x square root one.
Yep, square root function. And so what you'll notice is some of these will just have one thing and some of them will have like 5. So just make sure you pay attention to what it's asking for. And sometimes, like on a quiz or a test, there may be 5 that fit the thing and I just tell you to give me 2 of them. So just be aware of that. 16, the function that is not a continuous function.
Y equals integer x.
Yep. So y equals int of x. Okay, and that's because we said that this is not continuous on its domain. Y equals 1 over x is continuous on its domain, so it would be a continuous function even though it has a discontinuity. So that's why this one is the integer function. '18, the 4 functions that are bounded. So if I ever write BDD, that means bounded above. So this means that they have a max height value, like a max like above value, but that doesn't necessarily mean that they have one below.
Y equals
They could have, I'm just going to say they could have one below, but they don't have to. So which one?
y equals square root
Yep, y equals square root of x.
Y equals 1/1 plus 10 x.
Yep.
Y equals ln x.
No.
No.
I just realized something. Hold on. In number 18, this asks for the functions that are bounded above, but the square root function keeps going up and up and up, right? So that one would be bounded below, which will be one of your answers to number 17. So not that one.
You just do negative square root of x.
No. The reason I wrote that one down is because in the book the graph is reflected, so it's upside down, so it was bounded above by that stipulation, but just generically it is not bounded above.
Y equals cosine x.
Yep, y equals cosine x and y equals sine x.
It's not like 3.
Yeah, I think I need to change the question because, hold on. Like I said, that question is asked based off of the pictures that they gave in the book, which are not necessarily the base functions. They've manipulated them. So let me make sure. Yeah, so just change the question to be 3 instead, which is obviously not. Now, notice that on number 17, when you go to do that question for homework, it says the 6 functions that are bounded below. There may or may not actually be 6 that are bounded below of the base functions. That's based off the pictures that they gave you. So if you think you found them all and you only get like 4 or 5, just know that that is possible. Come back. Okay. Moving into the next ones, these ones just say to identify which of the 12 functions fit the description given. So, 20, the 6 functions that are increasing on the entire domain. So increasing means that as x is getting bigger, the y value is also getting bigger.
Absolute value.
No.
Y equals e to the x.
Y equals e to the x is 1.
Y equals x cubed. No.
Yes. Y equals x cubed because it starts down here and comes up. So as x is getting bigger, y is constantly getting bigger as well. What else?
ln x.
Yes. We have 3. We need 3 more.
Y equals x squared.
Nope. That has a point where it's decreasing 'cause it's a parabola.
Y equals x.
Y equals x. 2 more. And it doesn't have to start like in the negatives. Like it can start just wherever the function starts, it has to constantly be getting bigger.
Y equals 1/x.
Nope.
Square root of x.
Yep. Y equals square root of x. Because it doesn't start till 0, but every point after that, the y value gets bigger. And there's one more.
Greatest entropy.
Nope, not that one. It's another one we've used several times already.
1 over 1 plus.
Yep. So this one's probably the hardest to see. So let me show you why. So this value here, as x is getting bigger, this y value is constantly getting bigger. It's just approaching whatever this value is, but it's getting bigger by like decimals, like 0.0000. Like it's going to constantly get closer to that number but never hit it. And so that's because that's what an asymptote does. And so that's why that one is. So it doesn't necessarily look like it just looking at the picture, but that is what's happening. So let's see, 22. The three functions with infinitely many local extrema. So local extrema just means that it's where the graph is like hitting a maximum or a minimum point. In local ones, you can have a ton of those. You can only have one that's like an absolute max or min value. And so basically, which of the functions are continually like turning around and changing direction? Yes. This next one doesn't necessarily look like something that's turning around, but it has a lot of points where it will like be a value here, but below it, it was a whole,
Integer.
yep, the greatest integer. And that's because there's like little mins and maxes here at each of these values where they're occurring. And so these are all little individual extreme values. (24) The three functions with a range of all real numbers. So that means it takes on all y values from negative infinity to infinity. What functions would that be?
Does anyone have feedback in y equals x cubed?
Yep, x cubed.
ln
Yep, ln x
x.
and x, yep. Um, 26, the three functions with in behavior. So that just means what happens is x gets really, really big or really, really small, depending on the question. The limit as x approaches negative infinity of f of x is equal to negative infinity. So what this is saying is as my function gets really, really small, okay, so as the x value goes toward negative infinity, so it goes really far to the left, the y value also goes down to negative infinity. So what would those be? So as x gets farther to the left, y goes down.
Y equals b of x.
Nope.
Y equals 1 over x. Y equals 1 over 1.
So look, I'm looking as my x value goes to the left, y value is going down. So look for the one that as x is going to your left, y is going down.
Oh.
Y
equals
No.
x cubed.
X cubed is 1 because as x is going to the left, the y value is going down and it would go down to infinity. So y equals x cubed is 1. What else?
Y equals x.
Y equals x. And one more.
Y equals integer x.
Yep. Integer x. All right, one more of these. The two functions whose graphs are identical except for a horizontal shift.
Sine and cosine.
Yep, sine and cosine. Okay, so with this section, this is how the quiz and test will work with this stuff, okay? I will give you, or one of your questions will 100% be list the 12 basic functions, and when I say that, I don't want a picture of the graph, I don't want the name, I want it written like this, as either y or f of x equals, and whatever the function is, okay? So I'm telling you with certainty you need to be able to list all 12 of them. Then the questions that go with this will be stuff like what I wrote in black, okay? So the actual question that's from the book or one that I just did for you, like as an example before we got into the homework problems. You need to memorize those and be able, or you just need to understand what they're asking if you don't want to sit there and memorize them all. Okay, this is like one of the few times in math where like a Quizlet might be useful, at least in my class. So I've done all the even ones. You are going to do all the odd ones, and I'm happy to check them over with you, like as a group or whatever, once everyone's done them. So I'll say probably like Wednesday we'll check them. And we can go over the answers to make sure that, you know, you have them all and you know what you're looking for. But I will ask you questions like, state the three functions that have an end behavior with a limit going from x is negative infinity of the function to negative infinity. And you need to be able to list off those three functions. Okay, I tell you this now because next week, prior to junior trip, there's going to be a quiz. Okay?
Quiz or a test?
Quiz. It'll either be Monday or Wednesday because Tuesday is spiritual emphasis, so I'm not sure yet. And it also just kind of depends on how quickly we get through this. It could be Friday if we want to go ahead and get it out of the way. Actually, I might be thinking of the wrong class. Hold on. What day do I have it down in here? I actually currently have it set for either Thursday or Friday, so
Of next
Just-
week, right?
no, of this week. We have one more section to do, and 1.4 is not long. So, tentatively Thursday. I have a different class that has one on Monday next week. So, Thursday or Friday this week, you're going to have a quiz. So, I would say start memorizing. Don't wait till.
But so we're not
The
doing
last
all
day.
12 for
Yes.
next Thursday?
Yes. All right, your problems are 13 through 27 odd. And remember the ones 13 through 17, those ones may not be exactly like the quantity of them because of they're going with the graphs that they gave in the book, which are not all the basic functions. They've been shifted and stuff like that. So you're just listing the ones from your list of 12 that fit that description.